Good evening, students. This is a video on complex variables and analytic functions. Some gate questions are discussed here. Find the residue of the function f z equal to 1 by z plus 2 the whole square, z minus 2 the whole square at z equal to 2. First, we have to find the residue at z equal to 2. The formula is limit z tends to n d by dz z minus a the whole power n fz. Here we have to factorize this denominator z plus 2 the whole square and z minus 2 the whole square. So z takes the value plus 2 minus 2. We have to find at z equal to 2. So substituting z equal to 2, we will get z minus 2 the whole square fz. Here fz takes the value 1 by z plus 2 the whole square. Now limit z tends to 2, d by dz of 1 by z plus 2 the whole square is, use the formula d by dz of x power n x power n minus 1. So minus 2 by z plus 2 the whole cube. Now if you substitute z value 2, you will be getting minus 2 by 2 plus 2 the whole cube. That is minus 2 by 4 cube. 4 cube is 32. No, 4 cube is 4 into 4 into 4, 64. Cancelling 2 and 64, we will be getting minus 1 by 32. Now, the value of the contour integral mod z minus j equal to 2, 1 by z square plus 4 dz in positive sense. The formula is, you have to take fz as 1 by z square plus 4. So the denominator z square plus 4 can be factorized as z plus 2y into z minus 2y. So a square plus b square, z square minus 2i the whole square, 4i square minus 1. So z square plus 4. Therefore, z square plus 4 can be factorized as z plus 2y into z minus 2y. Now here in your question, mod z minus I equal to 2. So it is of radius 2. So z equal to 2i is a pole of order 1. Now residue of f comma 2i is limit z tends to 2i, z minus 2i fz. If you substitute limit z tends to 2i, z minus 2i, fz is this value 1 by z plus 2i into z minus 2i. Z minus 2i, z minus 2i get cancelled. So 1 by z plus 2i. So z equal to 2i. So 1 by 2i. Now the formula is integral z minus I equal to 2 fz dz is 2 pi I into sum of residues. Sum of residues is 1 by 4i. So cancelling I, 2, 4, you'll be getting pi by 2. This is a diagram having center I and radius 2. Now the integral fz dz evaluate around the unit circle on the complex plane for fz equal to cos z by z is, we have to find the integral value. The quotient function is fz equal to cos z by z. Denominator z can be written as z minus 0. Therefore, Fz has a simple pole at z equal to 0. Now, we have to find residue of f comma symbol pole 0. So limit z tends to 0, z minus a fz. A value is 0, z minus 0 fz. So substituting fz, we'll be getting z into cos z by z. Z get cancelled, cos z. Limit z tends to 0, cos 0. Cos 0 takes the value 1. So formula is 2 pi I into residue 1. So the answer is 2 pi I, option A. Now, an analytic function of a complex variable z equal to x plus iy is expressed as fz equal to u of x comma y plus I v of x comma y. That is, f is equal to u plus iv and z equal to x plus iy, where I is equal to my root of minus 1. If u equal to xy, the expression for v should be what? Here we have to find the expression of v. That is the imaginary part is v. U is the real part and v is the imaginary part. Here given u and v are analytic. Since fz is analytic, u and v are analytic function. Therefore, it satisfies Cauchy-Riemann equations or CR equations. Cauchy-Riemann equation is ux equal to vy and uy equal to minus vx. That is, ux is nothing but dou u by dou x and vy is nothing but dou v by dou y. So, u equal to xy, first you have to find dou u by dou x. If you differentiate u with respect to x, y constant, differentiation of x is 1. So ux equal to y, that is dou u by dou x equal to y. Now u equal to xy, uy. What is uy? Uy is x and vy. Vy is, what is the value of v here? V is not given. Okay. But CR equation ux and vy are same. So automatically ux equal to y. Vy takes the value also y by equation 1. So if we integrate v, we will be getting integral y. Basic formula integral x is x squared by 2. So integral y is y squared by 2 plus a constant. Since the limit is not given, we have to take the constant as c of x. Again, vx. Here, vx is differentiate equation 3 with respect to x. Now, vx is when you differentiate v with respect to x, y is constant. So, y square by 2 differentiation is 0. C of x is a function of x. Therefore, C of x differentiation is C dash of x. Now, CR equations, Cauchy-Riemann equation, uy is equal to minus vx. So, instead of vx, we can write minus uy. So, minus uy equal to C dash of x. What is the value of uy here? Uy is minus x. So minus x is equal to c dash of x. So c of, if you substitute here, c of x equal to minus x square by 2 plus k. From equation 3 we get b is equal to y square minus x square by 2 plus k. So the answer is C. Now next one is find the modulus of the complex number 3 plus 4i by 1 minus 2i. So 3 plus 4i by 1 minus 2i is equal to, we have to multiply both the numerator denominator by the conjugate of 1 minus 2i. That is 1 plus 2i by 1 plus 2i. Now numerator, first you multiply 3 with 1 plus 2i, we will be getting 3 plus 6i plus 4i plus 8i square. I square is minus 1. So solving we will be getting minus 5 plus 10i. Denominator 1 minus 2i into 1 plus 2i. A minus b into a plus b, a square minus b square. That is 1 square minus 2i into 2i, 4i square. I square takes the value minus 1. So 1 plus 4, 5. So we will be getting minus 1 plus 2i. Now the modulus of this. See, the formula is modulus of a plus bi equal to square root of a square plus b square. So here 1 square plus 2 square. 2 square is 4. 4 plus 1 is 5. So root 5 is the answer. The option is B. Now for an next question, for an analytic function f of x comma x plus iy is equal to u of x comma y plus I v of x comma y, u is equal to 3x square minus 3y square. The expression for v considering k to be constant is what? See, u given, we have to find the value of v. See, already we have learned that Cauchy-Riemann equation is ux is equal to vy and uy is equal to minus vx. So first we have to find the value of ux. U is given 3x square minus 3y square. If you differentiate u, you will be getting ux. Ux is 6x minus 3y square, differentiation becomes 0. So only 6x, ux equal to 6x. CR equations tells us that ux equal to vy. So substituting ux equal to uy, so both the values are 6x. Now v is equal to 6xy plus 5 of x. Now differentiating with respect to x, vx is 6xy differentiation with respect to x, 6y plus 5 of x differentiation 5 dash x. But vx is equal to minus uy. So we will write this as minus uy equal to 6y plus 5 dash x. So 6y get cancelled, 5 dash x equal to 0. If we integrate this, 5x equal to a constant k. So v is equal to 6xy plus k. The option is option D. Now singularities. Singularities means we have to differentiate, we have to substitute the denominator value equal to 0 and find the value of z. Question is, the analytic function fz is equal to z minus 1 by z square plus 1 has singularities at What are the points? Options are 1 and minus 1, 1 and I, 1 and minus I and I. First take the function f z. F z is z minus 1 by z square plus 1. See, the denominator z, z square plus 1 can be factorized as z plus I into z minus I. If you put a square minus b square formula, z square minus I square takes the value minus 1. So minus minus plus z square plus 1. Therefore, we can factorize z square plus 1 as z plus I into z minus I. Therefore, if you put the denominator value equal to 0, z equal to I and z equal to minus I. Therefore, the singularities are I and minus I, the option D. Next, using Cauchy integral theorem, the value of the integration being taken into counter clockwise direction, integral z cube minus 6 by 3z minus 1 dz is what? The options are 2 pi by 81 minus 4 pi I. B option pi by 8 minus 6 pi I. Third option 4 pi by 81 minus 6 pi I. Fourth one is D option is 1. Taking the function f z equal to z cube minus 6 by 3z minus I. Here f z has singularities at z equal to I by 3. Now residue of f comma 1 by 3 equal to limit z tends to I by 3 z minus I by 3 into f z. Substitute f z. Z cube minus 6 by 3z minus I is equal to 1 by 3 into I cube by 27 minus 6. We have to substitute the value z equal to I by 3. So we will be getting 1 by 3 into I cube by 27 minus 6. Formula is integral over C f z dx is equal to 2 pi I sum of the residues. 2 pi I into 1 by 3 into I cube by 27 minus 6. That is, we are substituting the residue value. So, denominator 27 into 3, 81. Numerator multiplying 2 pi I power 4 minus 4 pi I. I power 4 can be written as I square into I square. I square value minus 1, minus 1, minus 1, plus 1. 2 pi by 81 minus 4 pi I. Next question. Consider likely applicability of Cauchy integral theorem to evaluate the following integral counterclockwise around the unit circle C. I is equal to integral over C secant z dz. Z being a complex variable, the value of I will be option A, I equal to 0, singularity set equal to 5. Option B, I equal to 0, singularity set plus or minus 2n plus 1 by 2 pi, where n takes the values 0, 1, 2, etc. Option C, I equal to pi by 2, singularity set is equal to plus or minus n pi, n equal to 0, 1, 2, etc. D, none of the above. So, I value given, integral secant z dz, we have to find the integral of that. See, integral secant is a dz. What is secant theta? Secant theta is nothing but 1 by cos theta. Now, it is in the axis positive axis, we can take this as n plus 1 by 2 pi. If we put n value 1, pi by 2. N value 2, 2 plus 1 by 2, 5 by 2. 5 by 2 pi. N value 1 means 3 by 2. 3 pi by 2. Then 5 by 2. So odd multiples will be there. Suppose we are putting the negative values. N takes a value minus 1. So minus pi by 2. Minus 1 plus 1 by 2. So minus 1 by 2 into pi minus pi by 2. N takes the value 2. 2 to 4. Minus 4 plus 1. Minus 3 pi by 2. So we will be getting positive side pi by 2, 3 pi by 2, 5 pi by 2, etc. Left side minus pi by 2, minus 3 pi by 2, etc. None of these poles lies inside the unit circle mod z equal to 1. Hence, sum of residues at poles equal to 0. Singularities can be written as 2 pi I sum of residues of fz at the poles. Here, sum of the residues is 0. Therefore, 2 pi I into 0 is value 0. So, 0 and option is A. I equal to 0, singularity set is empty set. Now, next one, the value of the integral cos 2 pi z by 2z minus 1, z minus 3 dz, where C is a closed curve given by mod z equal to 1. The options are A is equal to minus pi I, B is equal to pi I by 5, C value 2 pi I by 5, D value pi I. Now, we have to find the value of this integral in the curve mod z equal to 1. Mod z equal to 1 means z is a circle with center 0 and radius 1. Mod z, it can be written as z minus 0 equal to 1. So fz equal to cos 2 pi z by 2z minus 1, z minus 3. Fz at singularity at z equal to 1 by 2. See, we have to solve this, solve the denominator. 2z minus 1 equal to 0, z minus 3 equal to 0. So z equal to 1 by 2 and z equal to 3. But it is a circle, z is a circle of radius 1. So only 1 by 2 lies inside and 3 lies outside. So residue of f comma 1 by 2 is, substitute z value 1 by 2. Limit z tends to 1 by 2, z minus 1 by 2, fz. Substituting fz, we will be getting cos 2 pi z by 2, z minus 3. Now, the answer is, if we substitute z value 1 by 2, the answer is 1 by 5. Integral over C fz dz equal to 2 pi I by 5. Next question. Which one of the following is not true for complex numbers z1 and z2? z1 by z2 equal to z1 z2 bar by z2 square. B is mod z1 plus z2 less than or equal to mod z1 plus mod z2. C option is mod z1 minus z2 less than or equal to mod z1 minus mod z2. D is mod z1 plus z2 to the whole square plus mod z1 minus z2 to the whole square equal to 2 times mod z1 square plus 2 into mod z2 square. Now, z1 by z2, we can multiply both the numerator denominator by z2 bar. So the value won't change. So z1 z2 bar by a bar equal to mod a square. Use the formula. So z2 z2 bar is mod z2 square. Now, B. B option is mod Z1 plus Z2 less than or equal to mod Z1 plus mod Z2. It is a triangle inequality law. Therefore, it is true. Third option, mod Z1 minus Z2 less than or equal to mod Z1 minus mod Z2. That is false. It is not a true statement. The true statement is mod Z1 minus mod Z2 greater than or equal to mod Z1 minus mod Z2. So, the question is, which one of the following is not true? False statement. Option C is a false statement. D option, mod Z1 plus Z2 the whole square plus mod Z1 minus Z2 the whole square equal to 2 into mod Z1 square plus 2 mod Z2 square. Suppose if you are taking mod left side mod Z1 plus Z2 the whole square, which is equal to A square equal to A into A bar. So Z1 plus Z2 into Z1 plus Z2 the whole bar. So Z1 plus Z2 into Z1 bar plus Z2 bar. We will multiply this Z1 Z1 bar plus Z1 Z2 bar plus Z2 Z1 bar plus Z2 Z2 bar. Again, mod Z1 minus Z2 the whole square is Z1 plus Z2 Z1 minus Z2 the whole bar. So we can write this as Z1 plus Z2 Z1 bar minus Z2 bar. If you multiply Z1 Z1 bar plus Z2 Z2 bar minus Z2 Z1 bar minus Z1 Z2 bar. So if we add the equations 1 and 2, we will be getting the terms Z2 Z1 bar get cancelled. Z1 Z2 bar get cancelled. Remaining is 2 Z1 Z1 bar plus 2 times Z2 Z2 bar. But what is A bar? A bar is mod A the whole square. So 2 into mod A square plus 2 into mod B square. Next one. The value of integral dz by 1 plus z square where c is the contour mod z minus I by 2 is 1. Equal to 1 is what? We have to find the integral. Answer A 2 pi I, B pi, C tan inverse z, pi I tan inverse z. The option is B. Next one, the value of the integral of the complex function fs equal to 3s plus 4 by s plus 1 s plus 2 along the path mod z equal to 3. So the meaning of mod z equal to 3 is s is a circle with center 0 and radius 3. We have to find the value of the integral. Integral 3s plus 4 by s plus 1 s plus 2. Now first you find the singularities. How to find singularities? Singularities is we have to factorize s plus 1 and s plus 2, substituting s plus 1 s plus 2 equal to 0. So s plus 1 equal to 0 and s plus 2 equal to 0. We will be getting the value s is equal to minus 1 and s is equal to minus 2, which are inside the given circle having radius 3. Radius 3 means left side minus 3, right side plus 3. So the values 1, 2, minus 1, minus 2 lies inside the circle. So both the points lies inside the circle. So we have to find the residue at minus 1 and also the residue at minus 2. So the formula is Residue formula is limit z tends to a is the pole, minus 1, z s plus 1 fs. Here what is fs? 3s plus 4 by s plus 1, s plus 2. So substituting, it will be cancelled, s plus 1 will be getting 3s plus 4 by s plus 2. Substituting s value minus 1, we will be getting the value 1. Now, next one, residue of f comma minus 2. Limit s tends to minus 2, s plus 2 into fs. What is fs? Fs is nothing but 3s plus 4 by s plus 1, s plus 2. If you cancel s plus 2, remaining is 3s plus 4 by s plus 1. Substitute the value minus 2, we will be getting 2. Now 2 pi I into sum of residues. What is sum of the residues? First one is 1 and second one is 2. So 2 pi I into 3. So 6 pi j. For the function sin z by z cube of a complex variable z, the point z equal to 0 is option A, a pole of order 3, option B, a pole of order 2, option C, a pole of order 1, D, not a singularity. As limit z tends to 0, sin z by z equal to 1. Substituting z value 0, sin 0 by 0. Sin 0 by 0 is 0 by 0, indeterminate. Therefore, use L'Hospital's rule. Differentiation of sin z is cos z, z value 1. So, limit z tends to 0, cos z. Substitute z value 0, cos 0, the value is 1. Therefore, function has z equal to 0 is a pole of order 2. Option B is correct. Contour C in the adjoining figure is described by x square plus y square equal to 16. The value of integral z square plus 8 by 0.5 z minus 1.5 j dz. J equal to root of minus 1. So we have to find the integral value. Here x square plus y square equal to 16 means x square plus y square equal to 4 square. 4 is a radius of the circle with center 0, 0. So we can draw this in the z plane. Now, what is the question f is z? Z square plus 8 by 0.5 z minus 1.5 j. So, if you take zero 0.5 minus 1.5 j. If you multiply by 10, 5 z minus 15 j will be getting. Then if we cancel, we will be getting z minus 3j. So fz has a singularity at z equal to 3j, which is inside the given circle is x square plus y square equal to 16. So residue of f comma 3j is equal to limit z tends to 3j, z minus 3j, fz equal to minus 2. So phi of fz ds equal to 2 pi j into minus 2, that is minus 4 pi j. Next question. Consider the circle z minus 5 minus 5y equal to 2 in the complex plane x comma y with z equal to x plus iy. The minimum distance from the origin to the circle is A option 5 root 2 minus 2, B option root 54, C option root 34 and D option 5 root 2. Here mod z minus 5 minus 5y equal to 2. If you take minus outside, z minus 5 plus 5y equal to 2. It represents a circle of radius 2 and center 5, 5. From the figure, see here, z minus 5 minus 5y. So the center is, you split this, z minus 5, open bracket, 5 plus 5y. So 5, 5y is the center. In the imaginary plane, 5, 5y, it is in positive axis with radius 2. So radius 2. So z equal to x plus iy in the plane, z plane. Now z mod z minus 5 minus 5y equal to 2. Z minus 5 plus 5y equal to 2 represents a circle of radius 2 and center 5, 5. So from figure, what is OP? So if we draw a triangle, this is a right angle triangle. By Pythagoras theorem, the square on the hypotenuse is equal to sum of the squares on the other two sides. So OP square is equal to, suppose if you draw a perpendicular line,